Oh, let me find my notes. All right, I think we're at the front of the second page. So we're working with what's called conjugates today. It's pretty easy. So yesterday we had three different definitions for acids and bases, and then I told you we would really stick with one, which is the Bronsted-Lowry. So this comes from that. So conjugates are part of the Bronsted-Lowry acid base definition. So conjugates work in acid base pairs. It's a pair of compounds that differ by an H plus ion. So it's not just that they differ by a hydrogen, they also differ by that charge. So from yesterday, we talked about the definition of Bronsted-Lowry. For that, an acid is a proton donor. Go ahead. Oh, I thought you would need to sharpen your pencil. And a base is a proton acceptor. So when we're working with these, we're going to be working with one equation, and in the reactants, you're going to be identifying the acid and the base based off of this definition, and then in the products, you're going to be identifying conjugate base and conjugate acids. That's what CB stands for. If you have an acid in your reactant, it's going to become a conjugate base in the product. And then if you've identified it as a base in the reactants, it's going to become a conjugate acid in the products. So acid and base are always in the reactant. The conjugates are always in the products. So if we look here, hydrofluoric acid HF, it went from HF to just the fluoride ion. So it got rid of one hydrogen. So that's why it's labeled as the acid. It was a donator. It donated a hydrogen to the water. So it was an acid as a reactant. Once it donated the hydrogen, what was left, which was a fluoride, became the conjugate base. They become the opposite kind of conjugates. Here, water went from H2O to H3O, and also went from neutral to a +1, which means it accepted that hydrogen ion. So if it's a base as a reactant, once it accepts that hydrogen ion, it becomes a conjugate acid. And the reason they become opposite types of conjugate acids is if I now reverse this reaction, you can see that now the conjugate acid has the hydrogen that can be donated, and the fluoride would have to accept it. So that's why they become the opposite types of conjugates. So I've already talked about most of this. We'll fill in the words. Hydrofluoric acid is referred to as the acid, and water is referred to as the base. The fluoride ion is referred to as the conjugate base. And the hydronium ion, the H3O plus, is referred to as the conjugate acid. All right, let's look at a few more examples of that, because really that's mainly what we're going to be doing today, and that's what the quiz on Thursday will pretty much be over, labeling those. All right, so I started off with HCl, hydrochloric acid. It went from HCl to just Cl. So it got rid of a hydrogen. So would it be the acid or would it be the base? Acid. If it started as the acid, once it gave away its hydrogen, it would be the conjugate base. So if that's an acid, then the water has to be the base. And sure enough, it went from H2O, two hydrogens, to H3O. So it is the base. And once it accepted that base, I'm sorry, that hydrogen, it became the conjugate acid on the product side. All right, why don't y'all try to label those other two equations? All right, on H2SO4, sulfurous acid, what would it be? It would be the acid because it went from two hydrogen, it gave one away, and then over here, it now just has one hydrogen. So that's my conjugate base. Water, once again, went from two hydrogen, it gained that hydrogen, and over here now it has three, so it would be the base. And then my last one, NH3, was it the acid or the base? Base. It went from NH3 ammonia to NH4 positive ammonium. So that means in this case, water actually donated a hydrogen. So it was the acid, and this would be my conjugate base. So what do you notice about water? That's right. It can be an acid or base. And that is called amphoteric. It's a compound that can act as an acid and base. So it either has a hydrogen to give away or it has a room to gain a hydrogen. And we'll look at a couple other things that are amphoteric in a minute. All right, so there at the bottom, talking about strengths of acid versus conjugates. If I start off with one of my strong acids, it will be a weaker conjugate base. So an acid's giving away a hydrogen. So that means that if I have a strong acid, it's more willing to give away a hydrogen than its conjugate is to accept. If I have a weak acid, then I have a stronger base. Not strong enough that it fits into our list of strong bases, but a stronger base than it was an acid. And the same thing here. If I have a strong base, it will be a weaker conjugate acid. Or if I have a weak base, then it's going to be a stronger conjugate acid. Not strong enough to fit in our list, but it's more willing to give up a hydrogen than the base was originally to accept it. All right. So on the next couple of little practices, you kind of have to work backwards to think of this. Because the first one says, what is the conjugate acid of the following substances? If I'm looking for a conjugate acid of these, that means they have to be, if I'm looking for a conjugate base, that means these have to be acids. Because the only way I can get to a conjugate base is if I start with the acid and I give away an H+. So if I start with H2O with 2 hydrogen, I have to get rid of 1. So it becomes OH, and it was neutral. I gave away a +1, so now it is a -1. So it's not just that you're giving away the hydrogen. You have to remember that hydrogen is an ion. It carries a charge with it. So NH3, I would give away a hydrogen, and it would go to NH. I'm sorry, I just said the answer. NH4, I would give away a hydrogen, and it would go to NH3. Originally, it was a +1, but that hydrogen took that +1 away. So now it's neutral. Why don't y'all try the last 2? Let's see what you get. And on D, on acetic acid, it's that first hydrogen that is given away. That's its acidic hydrogen. Those other hydrogens in the middle, those cannot be given away. All right, what would C become? NO2 negative, exactly. Because it's neutral, we give away a positive. And then my last one would become perfect. So now this is kind of the opposite. We're looking for a conjugate acid, so that means these have to be bases. So instead of giving away, I am accepting an H plus to get me from my base to my conjugate acid. So HCO3 would become H2CO3. And now no charge. It was a -1, but when I brought in my +1, it canceled it out. H2O would become H3, that hydronium plus. Perfect. All right, try those last 2. See what you get. All right, what are we going to get for C? PO4 negative. I had a -2, brought in a positive, so now I have a -1. And my last one, plus ammonium, exactly. A couple of things that are amphoteric besides water. H2PO4 -1 and HPO4 -2. Those would be examples. These come from phosphoric acid after it's given away 1 hydrogen or 2. So both of those have a hydrogen it can give away, and they also can accept a hydrogen. You don't need to write this. That's phosphoric acid. It can has something to give away, but it cannot accept a hydrogen. There's no place for it to accept a hydrogen. All right, try those last 3. Let's just label them as A, B, CA, and CB. And then you'll have a little time for practice. And then that's going to be what the quiz will be over Thursday. So hopefully that'll be pretty easy. Andrew, you might want to check. Well, I can show you that your grade, quiz grade is much different than it was graded by. All right, what do we got here? HBR. Oops. Well, maybe not. Acid. So my water would be my base. BR would be CB and CA. And H3PO4 base. And what do we get? CB or CA? And CA. And last one. Base, acid, CA or CB? CB, CA. Because look, this is, if this was my acid water, it lost one hydrogen, then it had to become the conjugate base. Here I gained, the base went from H3 to the conjugate. All right, so if you will, so you got a little time to do some practice. Hopefully, it'll be easy quiz for you.